So I had to continue from yesterday. Yesterday, we already talked about some statement, kan? Wait. Okay, just to recall from yesterday, I mentioned about statement and proposition. Whatever sentence that has true or false, it's called statement or proposition. Okay, and then we look at negation, right? The not is just the opposite. We look at conjunction. Conjunction is and the truth table you have to know both true, then you get true. All right, and disjunction is or. At least one is true, you will get true. Okay, all right, and then I give you an example. Okay, I want to see your hand. How many of you have read through these notes for this week? Kat tangan. Ada tak reaction? Reaction. Ada tak? I want to see. Do you have time to read? Tak sempat tak apa. I just want to know. Janganlah nangis. Ada reaction tangan turun bawah tak? Ni ke? Oh, ada thumbs down lah. Saya tak tolak markah lah. Tak apa. It's just Farhan kenapa nangis? Farhan? You just unmute lah.
Belum baca lagi.
Tak kisah, tak kisah. Bukanlah tak kisah. I mean, it was just yesterday kan. But I hope this weekend, this weekend you have the time to at least look at week 1 and then week 2. It's good to read in advance. But you don't have to, tak perlu kecup-kecup perut. Saya tak gigit orang. Tak cekik pun tak dapat cekik kat dalam ni kan. But the truth, bukan the truth table it's just share. I just want to know. Kalau sudah, it's okay. Alright. So I want to continue. Lepas ni saya akan masuk gear laju sikit ya. Alright. So I want to continue with another example. Right? P. Okay. P2 is a positive integer. You don't have to write if you don't want. If you want to type pun boleh, tapi ada kat situ lah. Just to save your time, so you can just focus on whatever I teach. Understand that is. Then you can refer later. And square root 2 is a rational number. So whatever example will be given, I won't give something extra that you have not learned. This is just all the basics. Okay. Now tell me what is the truth value of this. 2 is positive integer. True or false? You can type in the chat or you can just bising-bising pun tak apa. Kelas kita buat bising sikit. You can just unmute.
Yes.
Mana ada yes?
True.
True.
True, It's a T. True. Tak apa. You bising-bising pun ada saya dengar lah suara orang. Tak adalah cakap seorang. Okay. Square root 2 is a rational number. True or false?
False.
False. Why?
Because set 2 is irrational.
Why is irrational?
Because have a decimal number blah 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 like that.
Because it cannot be written as a fraction.
Kan? That's I mean.
Okay. You have to know how to prove that. Saya tak buat sekarang lah. Nanti It's not a rational number. Saya bagi peluang hint This will come later, but as a mathematician, or if you have a degree in mathematics, no matter SSCM ke SSCE ke, if you don't know how to prove this, you are not a mathematician. I cannot say you cannot say that you have a degree in mathematics. Senang je sebenarnya, but it's later, because you cannot write this as a fraction. Kan? Rational number is anything that you can write as a fraction, right? Integer over integer, but you cannot write this. Okay, anyhow, okay, so if I ask you, P or Q? True or false?
True.
True, huh? Okay, P and Q?
False.
False.
All right, senang sangat ni kacang. Okay, we go to the next one. Okay, go to the next one. Understand that in this class, it's mathematics equation, not English, right? Although you have to write a good English, but sometimes it depends on the statement. Okay. I want to write something. Any now was it is raining now, thus I'm not going to attend my discrete mathematics class. Why? There is no why here, it's just a statement. Okay? In your place now, is it raining or not? No.
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 No? No. Ada orang kat Melaka tak? Anybody in Melaka now? Yes? Melaka dengarnya banjir ya. Okay, so those who is not raining now, okay, if it rains, this is the next one. If it rains, that you won't be attending the class. Okay, now it does not rain. So meaning you will be attending the class. Okay, although whatever it is, you say this whole statement is true. For those that is raining now, then this statement will be yes. Okay. For those who are not raining now, this statement is false. Okay, that is my next point, that 1.3 is implication. Yeah? You will understand this after I give you the truth table. Okay. So this is if P then Q, right? If P then Q. Okay. Okay, so we have P, we have Q. How many rows? Because you have two variables, 2 squared, you have 4 rows. So true, true, false, false. True, false, true, false. For P implies Q, okay, this is false. This is false only. This is false only if it's true implies false. Dia punya formula dia lah. Right? The rest will be true. Okay, it will be false only if this is true, this is false. Otherwise, it will always be true. Okay, another way that you have to know is that if this part is false, it will always be true. If this part is false, it will always be true. All right, so I will write an example. If 2 plus 3 equals 4 and 5 and reach. Okay, what's the answer of the whole statement? True or false? What's the truth value of this sentence?
True.
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 Anybody say false?
True.
What if
Because
say false?
P 2 plus 3 is 4. Q, I am rich. 2 plus 3 equals 4 is false, right?
False.
Doesn't matter if I'm rich or I'm not rich. It's always false, implies whatever is true. Okay, so that's why I said this is mathematics statement, not English. So it doesn't matter whether I'm rich or not, but the first one is already false, so the whole thing is true. Okay. If the first one is true, it depends on this one. Okay. If, but I won't give you this because you probably will give a different answer to I am rich or not, right? If I give you a question like this, then this is true, and then depends. Some of you are not rich, some of you are rich, some of you pretend to be rich, pretend to be not rich. But anyhow, this is implication, yeah? Okay. Now the next one is, okay, if there is other example in the notes, you can look yourself. Equivalence. Equivalence. And sometimes people call it as biconditional. Okay, and it's if and only if. If and only if. Okay, we say P, if and only if. You have learned this, right, in set theory and logic. So this is called the antecedent hypothesis, or this is the consequent or conclusion, yeah? I'm not gonna repeat that. Okay, now this I add another one, yeah? So this is only true if both are true or both are false. This is true if both are true or both are false. Itu dia punya ni lah. Alright. Okay, you can fill in the table there. Leave it blank. Okay, that's an example there. 3 bigger than 2 if and only if 0 is less than 3 minus 2. Okay, 3 bigger than 2 is true if and only if 0 is less than 1, true. So the answer is true. All right. So you just put the truth value to the statement, and then you can apply this. Okay. Now the third one is converse. Converse and contrapositive. All right. If you want me to repeat anything, if something is not clear, don't type in the chat. Chat kadang-kadang saya tak nampak pun. Or someone else can help and read or unmute. Saya bukannya tengok sangat ni. Okay. Just feel free to unmute. Yeah, Seni? If you need to video on, nanti nak pergi toilet ke apa pun takut, it's okay. You can nak pergi take water ke, take something to drink ke apa, jangan pergi jauh-jauh sudah. But itu kelebihan dia lah kan. Kelas. Alright, okay. So converse and contrapositive. Right. We have this implication. Okay, we have this implication. The converse is this. That's the converse. But most of the time, the converse is not true. Okay, most of the time. But if it's a double implication, just now, the converse is also true. I didn't write it out, but this means this and this. Yeah, it's a double implication for this one. So both are okay. All right, so P implies Q. The converse might be not true. Then you can write in the table. Okay, what is the padam pula. So I put smaller, Okay, true, true, false, false. True, false, true, false. Then I said this is false, otherwise they're all true. So Q implies P. You see, Q implies P is this implies this. True, right? False implies true. True implies false. 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 It's not the opposite, right? It's not just the opposite. It's this. 3 also. Okay, so they are not just, so you can say this is not this. It's not. Because if this like this, you will get T and F, right? 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 Yang pakai topi tu, goyang-goyang sikit saya dah nampak dah. Dia punya gerakan. Alright, okay. Now that is the converse. Now, contrapositive. Okay, contrapositive from this implication is not Q implies not P. Can you write? Tak muat dah ni, tak muat dah. Not Q, not P, and implication. See what do you get in the truth table. Oh, adalah dia punya. Ada kat belakang. Biru pula. Okay. You see the ada kan? Not Q, not P, not Q implies not P. Okay. Right. Okay, now this one, how do you say it? If P then Q. Okay, if P then Q. Sometimes you say Q if P. Q if P. P only if Q. Some of the things that you might be given as a question, right? The only reason for P is Q. That's a little bit weird. P, this is very common. P is a sufficient condition for Q. P is a sufficient condition for Q. Q is a necessary condition. So that's why we always say it's sufficient, but sometimes it's not necessary, or sufficient and necessary conditions. You will always hear this, especially later. Okay, so I'm gonna go next to the statement that is called tautology. It's very easy. A tautology is if everything in that column is true, right? Everything in that column is true. So in that table, I give you this. You have to fill out, what is this? You have to fill out the last column. Okay, P implies Q is this. Not Q implies not P. It's the same thing, right? Not Q implies not T is the same thing. So this is the same as this, TFTT, TFTT. So all will be TTTT. All true, which is a tautology. Another one is, this is actually similar. P or Q or Q or P. Right. Okay. Okay. Another one is called contradiction. Just now is contrapositive, don't get confused. Contradiction is also absurdity. Okay, absurdity. In which it's always false. Just now, this always true. This one always false. Easy if we have P and not P. Right? P and not P. If you have P, TF, not P will be FT. So P and not P will be FF. Right? Let me try and see myself whether I can see my board. Okay, that's clear. All right. That's clear. Saya pun tak tahu apa bentuk dia sebenarnya. If I don't see like this. Okay, my view now is gallery, so I can see you. Okay, that's done. Okay. Contingency. If it's mixed, we call it contingency. Okay, you can have a mix of true or false. Okay, there's a blank there in the table that I want you to fill out later and see whether you can understand that. Okay, next will be, this is just like review, right? You have learned all this. Lupa ke, ingat ke tidak? Yeah, Amirul, you remember this or not? Negation, negation of a sentence. Okay, so we want to see, for example, I think you have learned this before, right? You want to see whether this is the same, like a distributive law, right? You can show this using truth table. They are the same. If you want to do this, terbalikkan kan? This one. Okay. All right. How many of you here? 36. Okay. Now, there is this one formula that you have to remember, yeah? Okay. Tiba tekak kering. Okay, this one is very important. P implies Q is not P or Q. I'm sure you still remember this from your set theory and logic. Because sometimes you need to change the implication in terms of disjunction, conjunction, and negation. Like the example, you need to change this in terms of only disjunction or conjunction or negation. So you will write not P or Q, right? Not is back and this, right? Not. Okay, so you get this. All right. Okay, next is quantified sentences. You have also learned this in a bigger scale or larger scale in your last class. Quantified means there is a quantity. There is a quantity meaning that there is like for all, for some, for each, okay? This is called the universal quantifiers. So we start with universal quantifiers. Universal quantifiers. And the symbol is A terbalik. A terbalik. The other one is E. Sungsang kan? Okay. You call this for all or for each, for everyone, for anyone. Okay, but normally we will use for all or for each. Okay. Now next is to convert each sentence to a symbolic form. Let's try to do this. So first example. For each real number x squared is bigger than 0. Okay, there are many ways to do this. You can just write for x in R, for x in R, x squared is bigger than 0. But you can also put px, x is a real number, qx, x squared bigger than 0. So for all x, px implies okay. And I have 3 more examples. All cats have fur. All cats have fur. Cx, x is a cat. Fx, x has fur. Okay. So for each a cat has fur. You can still do Cx imply Fx. All cats have fur. All human beings are mortal. Again, Px, x is human being. Qx, x is mortal. Then you have the implication. All brave soldiers are heroes. If it's a brave soldier, then it is a hero, something like that. So normally we will use this one for the universal quantifier. Okay. All right. Then there is more example. Okay, there is more example that I want you to try and fill out the answer. I'm not going to give every single one. This is just a good exercise, right? For you to try to put the answer. Anyone will be angry if he is provoked. So already give Px, x is angry, Qx, x is provoked. So anyone will be angry if he is provoked. Okay. Anyone who is lonely is unhappy. Anyone who is sick feels miserable. everyone is sick and miserable. Don't think about the English, think about putting in the symbol. Okay. Try to, if you have, I don't know if you have, how do you refer to your notes while having Zoom, but semua cerdik-cerdik kan. Okay. So is this example 112? Example 112. I will give you 10 minutes. Mau lamanya 10 minutes. 10 minutes, including the toilet break, yeah? For page 10 until page 10 until mana ni banyaknya? Page 15, 10 until 15. Okay, we will compare our answer. All right, if you don't need to go grab something to eat or drink, but I give you about, now it's 9 minutes. Okay, to do example 112, 113, mana 114 eh? I don't see. Oh, 114. And 115. Okay. Then I will start with the other one. We finish with this, then we do this. Okay, let me grab my drink. All right. Okay, so you will see that in all the examples, okay, in all those examples, actually the answer is this, right? Okay, although all the sentences are different, but it gives the same meaning. If for all x, if the first sentence, then the next sentence. For example, just now example 112, for each real number x, x squared bigger than 0. So you let the txx real number, qxx squared bigger than 0. So for all real number, x squared bigger than 0. All cats have fur, so you have cxx is a cat, fxx has fur, all cat has fur. For all x, cx implies fx. So in all of these examples, is all for all x, the x implies qx. Example 113, what is the truth value? X bigger than x minus 1. X bigger than x minus 1. Which is always true, right? For all. True for all. If it's not true, not for all, then you cannot say it's true for this. Then you go to the existence, the second one. Remember this, you don't really probably see this in everyday life, but once you start your project, your research, some of these things will appear. Yeah. Okay. Example 114, the first sentence, anyone will be angry if he is provoked. Anyone will be angry if he is provoked. So you can write your px and px, x is angry, qx, x is provoked. For all x, it will be angry if it's provoked, right? So you will put that as that. If you are lonely, then you will be unhappy. That is why it becomes anyone who is lonely is unhappy. If you are sick, then you feel miserable. Anyone who is sick is miserable. So you can put sick here, miserable here, and you get the same answer. Okay. The next one is example 115. This is quite important to write in a natural language, not directly translated mathematics sentence from this, but natural language. So this is to make it nice. For all x, ux implies rx or sx. What is ux? Ux is mathematics UTM-STU. Okay. Rx, X enrolls in this class. Sx, X enrolls in, what is this class? SSCM. You know what this class is? Kelas apa ni? Tak ada. Haven't taken. Whatever lah ya. Another class. Okay. So you want to write this. When you first translate directly from mathematics to replacing the sentence, you will say, for all x, if x is a mathematics UTM student, then X enrolls in SSM 2673 or X enrolls in SSM 3793. Okay, but that is not a natural language. Natural language, every day you don't say X, 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 right? So when you change, you will say all mathematics UTM student enroll in this course or this course as given in my example. Okay, so enough on the universal quantifier. We start with this symbol. The original E, just now A becomes this, right? Because you cannot do mirror, it will be the same thing. E, you cannot do like this, flip, because it will be the same thing. So you do mirror to change, right? Okay, now this, it's said to be there exists. There exists, there are some, someone, at least one. There exists meaning at least there is one. Maybe there's some, but not all. Yeah, that's how you say it. Okay, convert each of the following sentence to symbolic form. There are things that we are one of those things, right? We grow. Ada orang yang tak grow ke? Bantut kan? Okay, so Px, X grow. Px, X grows. So there exists X grows, right? So there are things that grow. All right. Ni kesian. Someone is lonely and unhappy. Do we have that someone in this class? Ke semua happy? Semua tak lonely? Okay. If not in the class, maybe in the world, right? Someone is lonely and unhappy. So here just one, this two, right? So you have Px, X is lonely. Qx, X is unhappy. And that is someone, it's not everyone. So there exists X, Px, and Qx. Someone is lonely and unhappy. Okay, so you can read through the rest. There's another one. There is someone who feels unhappy whenever she is lonely. There is someone who feels unhappy whenever she is lonely. Okay, it's different from here. If she is lonely, then she will be unhappy. Not always lonely and unhappy. Okay, and that is also someone who is unhappy and lonely. It's the same thing, right? Okay. Okay. If you want to see real math, this will be the example 117. Px, X is bigger than 5. X. Okay. Now the question is, what is the truth value? Is there exists X in which X is a real number and X is bigger than 5? The answer would be, Shakir? The answer should be true. Because there are numbers bigger than 5, although not all, right? Okay. Now I go to negation of quantified sentence. Negation of quantified sentence. Okay. The first thing that you have to know is, if you have for all x px, the negation of this is there exists X, not X. Right? The not this becomes this, then bring it to Px. Okay. The second one is not of this. Okay. This one, it becomes for all X, not X. Okay. What if you have both? For all X, exists X, X, then you have the negation. So you bring here, you have this. You bring here, you have this. And you bring here, you have this. Right? That's last one, right? Please add number 4. Okay? Number 4 will be this first, and this, which is for X, there is this X, not X. All right? Sometimes people put the parentheses here. Okay. All right, let's try to do some example to translate the negation. All right. Okay, number 1. For X, X in A, or X in B. Okay, you don't know what X is, but for all X, either X is in A or X is in B, right? So this is just any set. Okay, now this is equal to the exists X, and you have to take this, right? Okay, which is X not in A, not X in A is actually X not in B, right? And X not in B. Yeah. Oh, can't do something. All right, so, okay, that is number 1. Number 2, for all X, Px imply Qx. So, do you have the negation of the implication? No, right? You don't have the negation of the implication, but you can change the implication into or and like just now. So what you have to do is you put this as the existence, okay, not Px imply Qx. Okay. So, right. So this is equal to, so you don't have the negation of the implication. Let me hear your voice. I can see Alia. Alia? Can you? Yeah. What do you have to do? To change this implication into
Or
or, right? So just now P implies Q is not P or Q, right? So not P or Q. Okay, I give you a hint already. Say it louder. It's quite not becomes PX. Okay. O becomes N. Right. And then there is a not.
UX.
Right? Okay. Is it clear to everyone? All right. All right. Okay. I will leave number 3 for you to try. That's the answer there. Okay. Let's translate. This is not translation English to Malay. Yeah? Translate each of the following. Okay. Right. Translate. Number 1. Not everybody is happy. Okay. It's not a good example, right? I should put everybody is happy, but that's not the real truth. Not everybody is happy, so we let HX to be X is happy. Okay, so try to change the sentence into symbolic form or symbols. Not everybody is happy. Not everybody, not everybody is happy. So you can put like this. Okay, which is actually, you don't have to put parentheses. It's okay. Okay, so not everybody is happy, meaning you can bring the negation, change into existence, bring the negation to this, then you can read this as another sentence. Not everybody is happy means somebody or someone is not, right? Okay. Somebody or someone is not happy. The second one is really an extreme. The second one is really extreme, in which I say nobody is happy. Nobody means there is no existence, right? Nobody is this, right? There is non-existence of this, okay? So nobody is happy. The negation of the existence of HX. Then this is equal to, okay? That is equal to, for all X, not HX. For all X, not HX. How do you say it in English? Oh, in English. This is everybody. Everybody is not happy. Okay, so read the question carefully, whether they want you to just write in English, lateral language, or they ask you to find the negation. If you have to find the negation of the original sentence, then you put another negation. Then you will put another negation outside. All right. Okay. The next is no birds can fly. So you can put fx, x fly. No birds can fly, right? No birds means non-existence. Okay. Right, and that. Okay, now we want to see the truth value of this quantified sentence. The truth value. Just now, we just do the truth value for and for or just one, right? This quantified sentence is different. Okay, in which truth value analysis of quantified sentence. Okay. All right. Now, okay, we have to have a solution set for all the statement, whether it's existence or it is for all. If it is for all, then you have to find all true before you get the truth value to be true. If it's only existence, at least one is true, then it's true for all. It's just that simple. So it's like quite similar with the or and the and, right? The or means just any one is true, then it's true. For and means all has to be true. So the existence and the for all quantifier has very something similar with the or and the and, right? Okay, let's try to find one example. All right. Okay, let me see. You have to have the universal set. Your universal set can be infinite, it can be finite. So in this case, it's finite. You know why we call it a discrete? Discrete, like the difference between discrete and continuous, you know, right? If that's discrete, and if you have something continuous. So you should actually know why this is called a discrete math. I'm not gonna go, you can Google later, okay? So this is the statement. X is in between -2 and 2, okay? Then you can see the universal set might not be cover all, but I want X to be -2 and including 2. Qx is that X is less than 2. The absolute value of X is less than 2. All right, so we want to find the truth value of Px implied Qx. Okay, this is just all calculation, simple algebra. Then what you need to do is you have to put all the U, right? So you have to have all the U, element in the U. And then you have to have the X, right? And the X is in between -2 and including 2. So I put here before I forget. Px is, oops. All right, so you have to check. Is -2 inside here? No. This? No. This? Yes. This? No. Okay, so just check with this. And then the next one is Qx. Qx is the absolute value less than 2 and not including 2. It's just less than 2, not including 2. So this one is 3. 3 is not less than 2. false, all false, right? I can change this to equal and 2 will be okay, right? So it depends on the inequality. Okay, so then you go to the implication. You go to the implication. False implies false, true. False implies false, true. True implies false, false. I think these are all just quite straightforward. And the solution set, the solution set is defined to be, the whole thing is when it's from all here, when you have it true. Okay, so the solution set of this statement just now, the whole statement just now, sorry. Okay. Where is it? Where is it? True, true, true. -3, -2, and 3, which is not actually equal to the whole one because there is a false. All right. So if you are asked to find the solution set, what's the tongue twister? You just choose the one that's true. All right, that's pretty easy enough, yeah? Okay. How do we do it when U is infinite? How do we do it when U is infinite? So you can just see and check for some. It's quite hard to see, for example, x squared bigger than 0. X is a real number, right? You cannot put all the value of x because it's infinite. But you can draw, right? When the case x is a real number, but if you are given x bigger than 0, this is not including, and you will have x squared has to be bigger than 0. So in this case, this is true for all, but you cannot list like this because it's not this. It's not finite, it's infinite. All right. Okay. Now I go to look at proposition 1.2. I will write it if you don't have your notes with you. Okay. Proposition 1.2. Okay, the first one is that exists x, px is true if the solution set of px is not empty set. Because this is the exists, right? I mentioned about the or, if there is at least just one, then it is true, right? At least one. So you cannot have empty solution set. All right. Second one. This is false. Likewise, right? If this is empty. Right. And it should be there somewhere, but I don't know where it is now. For all, where is it? Oh, I missed that. Proposition 1.1. Sorry. I should mention this first. Reverse pula, eh? Okay. For all x, px is true if the solution set is the whole of U, right? True, 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 true for all. And for all x, px is false if the solution set is not U. Okay, because it has to be all true before you can accept the whole quantifier, the universe one. Okay. Okay, what time is it now? Okay, I have time to share some more example. Okay, okay. Okay, let me share example 1.23. You are so quiet, guys. Ada lagi ya? It's just like talking to yourself, right? If it's in the class, I can see like, and then you can talk to your friend. Right now in Zoom, how do you talk to your friend? You just go, right? There's nobody there. Jangan main chat-chat pula kat situ. Private chat. All right, okay. You can reply there, I can see. Okay, now this U is -2, -1, 0. And show for all x, x squared equal to x plus 1 is false. See the symbol for all x. And you have to show this is false, meaning somewhere in your answer there has to be an F, right? So your U is not that many. -2, -1, 0. Okay, and you can put this. You can put all like this px, or you can put different columns. What is x squared? What is x plus 1? Or you can just do it in your head. Okay, this one says 4 bigger or equal to -1. This one says 1 bigger or equal to 0. This one says 0 bigger or equal to 1. So the truth value of this is true, true, false. Yeah. If you don't put this and this is wrong, I cannot give you partial mark. Probably this one is right, but this one is wrong. Somehow I can give you partial mark for this, right? If this one is wrong, suddenly this one is right. Supposedly no marks, because that means you don't understand. I don't want to say you copy, but it has to tally. If this is right, this is wrong, maybe you make a mistake, right? If this is wrong, I don't know how you get this. Okay. Now, my comment just now is on example 1.24, in which something similar, okay, something similar, but let me show you. Example 1 point. Okay. U is the set of all real numbers. Okay. Find the truth value for this. How do you get this? Okay. Let me first show you the kata conteng, the draft sheet that is not shown there. But if you draw real So you have to remember your calculus or your, right? X squared and alamak. Landai ke sikit. So I can, yeah, see this, right? Right, they intersect at 1. Okay. X, Y. Okay. This is y equal x. This is y equal x squared. So you see, the one that x squared is bigger or equal to x is not this one, right? This one is y equal x is bigger than y equals x squared. So the one with x squared is bigger than x. Something warna. This is x squared. Okay, best pula warna-warni. Okay. All right, so you see x squared is bigger than x squared. So this way, so this. Okay, and x squared bigger than this here, right? Yes, in between this, it is not bigger. So you know that for this one, the answer will be false, right? The answer will be false. And how would you write this? Is to write the solution set of x squared bigger than x or equal to, and you can bring it to the other side, right? And then you can factor, right? X minus 1, so you know it's between 0 and 1, and the other one like you did before. So you can write this as x in R. I do it through here, but you can solve it like what you solve in calculus, right? Or which is not the whole real number, which is not the whole real number. Okay, so this is false. All right, just one example to show that sometimes the universe set is infinite, that you have to think the whole solution. Okay, so that's it. All right, example 1.26 is the last one that I want to share today, right? Before I stop. Okay. At least I can walk around, diri-diri, right? Duduk sikit pinggang lama-lama. If you want to exercise, bangun, akmal dah gini-gini dah, right? Exercise sikit. Diri ni sedap sikit. Okay. So I have this set D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, after today, I will look at your attendance for the 2 classes. If I see someone who is in the e-learning and you are not in the class for these 2 days, most probably you are not joining the class, I will remove you from the e-learning. So if you know that's your friend that failed to come for these 2 classes, but is actually planning is actually supposed to be in the class because of certain problem like health problem, something, let me know. Let your friend know. So let me know before I remove you, yeah? I will clean the WhatsApp group, I will clean the attendance, and I will clean also the e-learning. And after this, I will automatically invite all of you in the Google Calendar. So if I don't remind or forgot to remind you in the WhatsApp group of the link, you can just click your Google Calendar for the Zoom link. The Zoom link is supposed to be the same for the whole semester. One from yesterday that I use for Wednesdays, and today that I use for Thursdays. Should be okay to use the same two links, yeah? So if someone else joining but late, but someone else is there but you forgot to delete, you can let the person know. All right, so I get the clean list. Okay, so for this one, we want to make a list of members of D that makes the statement true. Okay, so the first one is, ni kacang sangat ni. Okay, X bigger or equal to 8, X bigger or equal to 5, and X is even, X squared is X bigger than 0, X bigger than X squared. And I also have to find the negation. Okay, and negation. All right, Shiham, the names that I call today,
Okay.
alat panggilnya, suara siapa tu?
Soalan nak buat.
Okay, Shiham. Ni mana tahu Shiham tiba-tiba dah ada anak yang saya tak tahu eh. So I don't ask you. I actually I wanted kalau dalam kelas kan call you to the whiteboard and share your answers kan. Tapi macam mana nak buat ni kat dalam Zoom. But today ada 5 ya. Saya panggil Akmal, Amirul, Sneha, Syakir, Alia for today ya. Okay? Patana tak cukup soalan. Boleh next time. Okay, Akmal. Can you give me the answer for this? What's the answer?
The answer true for 8, 9, and 10.
8, 9, 10. Now that's the solution set. It's true for 8, 9, 10. And what's the negation? The negation will be X less than?
Less than 8.
Which is?
1 to 8. 1 to 7.
1 to 7. Okay. All right. Next is Amirul. Macam ngeri kan nama dipanggil, but it's actually good for you. You will be braver. Kalau dah brave, braver. Okay, Amirul.
Okay.
Mana? Ni apa ni? Siapa tulis ni? Okay.
For 6, 7, 8, 9, 10, true for at greater than 5, and is even 6, 8, 10.
Okay, so the answer is
6, 8, 10.
This one just now is 8, 9, 10.
10.
And negation will be the rest, right? The negation. Yang bukan lah yang bukan.
Bukan.
Okay. All right, next is Neha.
Yes, Prof. For 3, X is 1.
1. Tu je. Tu je. Okay, that right? The only one because 0 is not there, right? If 0 is there, 0 will be there. Okay, Syakir. Syakir.
All X. X is greater than 0, so it's true for all X. Yeah. One.
Okay, for all X in D. Yeah,
Yes.
we just put the set D. Okay, last, Alia.
All false.
All false. So the answer will be empty set. Okay, X will never be bigger than X squared for all those. Yang tadi tu, pergi padam pula lukisan. Kan, X will be bigger just in between 0 and 1, right? So if it's 1, it's not bigger than, okay? All right, so we are done for today.